Section 4.2 Graphs of Exponential Functions. Learning objectives. In this section, you will graph exponential functions and graph exponential functions using transformations. So let's start with two functions here. F of x is equal to 2 raised to x, and g of x is equal to 1/2 raised to x. So we graphed this last time from section 4.1, f of x equal to 2 raised to x, whereas I showed you 2 raised to 0 is 1, 2 raised to 1 is equal to 2, 2 raised to 2 is equal to 4, 2 raised to 3 is equal to 8. Also, 2 raised to negative 1 is the same as 2 raised to 1, which is 1/2, or 2 raised to negative 2 is 1/4, 2 raised to negative 3 is, yes, 1/8. So that's why you have this exponential graph. That is f of x equal to 2 raised to x. And the other one, g of x equal to 1/2 raised to x. So we can start with 1/2 raised to 0. Any number raised to 0 is always equal to 1. 1/2 raised to 1 is equal to 1/2. 1/2 raised to 2 is 2 squared is 1/4, and 1/2 raised to 3, 1/2 times 1/2 times 1/2 is 1/8. So you have this point. And same thing with 1/2 raised to negative 1. Oops, I need a bigger space here. So 1/2 raised to negative 1, that is like 1/1/2. So that's why that is equivalent to 2. Okay, same thing with another one. I'm going to show you raised to negative 3. 1/2 raised to negative 3, that is 1/1/2 cube, and that is 1/1/8. And get the reciprocal of this, 1 times 8/1. That's why it is equal to 8. And we know that the x-axis is an asymptote, a horizontal asymptote on both. So what do you notice about this graph? Oops, sorry. Your g of x compared to your f of x. Yes, this is what you call it as a horizontal flip. So look at your yellow here. A horizontal flip is going to be, oops, sorry. Oops. Let me erase this. It's going to be a horizontal flip, just like this, your g of x. Let's compare and contrast the behavior of these exponential graphs. One with b greater than 1 and one with b less than 1. So we know that b greater than 1, always remember that the graph is like this. And if your b is between 0 and 1, then it will be again a horizontal flip. Okay, so take note of that. All right, graph using transformations. All the rules that we learned back in chapter 1 apply to exponential functions too. So graph the parent function f of x equal to 2 raised to x along with g of x equal to 2 raised to x plus 3 and 2 raised to x minus 3. So we have f of x, g of x, and h of x. Okay, so let's start with f of x equal to 2 raised to x. We know that 2 raised to x when it's 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8. And what else? 2 raised to negative 1 is 1/2. And we have a horizontal asymptote here. So our graph is like this. So this is f of x equal to 2 raised to x. So this is 2 raised to x. Then g of x, I'm going to use green, 2 raised to x plus 3. So meaning all these points from the graph of 2 raised to x, 2 raised to x plus 3, meaning up 3. So all the points, you just move it up 3. So 1, 2, 3. Oops, it should be green. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Should be somewhere here. Okay, and your asymptote is also, you go up 3. 1, 2, 3. So you're gonna have a, think about, you have a horizontal asymptote here. So now that is your new graph. So this is your g of x. Okay, so again with these points here. Okay, then the other one, two x raised to negative 3, negative 3 meaning, yes, that is correct, down 3. So all the points, including the horizontal asymptote, let's go down 3. So 1, 2, 3. So you should have a horizontal asymptote here. So this point, 1, 2, 3. 1, 2, 3. From this point, 1, 2, 3. From this point, 1, 2, 3. And another one from this point, 1, 2, 3. Now let's follow this. So you have this graph. Okay, so this is your 2 raised to x minus 3. The orange one is 2 raised to x plus 3. It doesn't look good, sorry. 2 raised to x, exponent x, plus 3. Okay? Next, example 2. Graph the parent function f of x is equal to 2 raised to x. Here, g of x is equal to 2 raised to x plus 3, and h of x equal to 2 raised to x minus 3. So now, what are the differences between these 3? 2 raised to x plus 3 meaning Yes, left to the left 3. And 2 raised to x minus 3 is, yes, right 3. So you just move your exponential to the right 3. Okay, so again, let's start with our 2 raised to x. So we have, remember, horizontal asymptote here, y is equal to 0. Don't forget, horizontal asymptote at y is equal to 0. 2 raised to x, when we graph this, negative 1 is 0.5, at 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 cubed is 8. So we have this graph. Oops, let me use red. So this is 2 raised to x. Next, 2 raised to x plus 3. So again, left 3. So we move all the points to the left 3. So 1, 2, 3. This point 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 1, 2, 3. With the same asymptote, horizontal asymptote of y equals 0. So it's gonna be this graph. So with these points, okay. And the other one, h of x, 2 raised to x minus 3 to the right 3. So all the points from here, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So same horizontal asymptote of y equals 0. So this is 2 raised to x minus 3. This is 2 raised to x plus 3. And this is 2 raised to x. Okay. So reflections, vertical and horizontal reflections work just as before. So example 3. Graph and write the function for reflecting the parent graph f of x equal to 2 raised to x. So we're always using this. Across the x-axis, vertical reflection, and across the y-axis, we call it as a horizontal reflection. So I'm gonna start again with our f of x, which is 2 raised to x. So we know that this one is 2 raised to x. We want the vertical reflection across the x-axis. Then it's gonna look like this. And a vertical reflection, that is negative 2 raised to x. So again, we call this a vertical reflection. Okay, and then horizontal reflection is, how do we do that? It's gonna be something like this. So this is your 2 raised to negative x, or it's the same thing as 2 raised to negative 1 raised to x, which means 2 raised to negative 1 is 1/2 raised to x. Okay, so we call this as a horizontal reflection. Okay, so you know that we have all this horizontal asymptote at y equals 0. Okay, so take note of all this. Vertical reflection, that is negative 2 raised to x. We have the horizontal reflection, that is 2 raised to negative x, and it's the same thing as 1/2 raised to x. Okay, and last page is about some lecture questions. For the following exercises, graph the transformations of f of x equal to 2 raised to x. Oops, that's not a highlighter. Give the horizontal asymptote, the domain, and the range. So let's review the graph of all these three. So I'm gonna sketch it real quick. Of this 2 raised to negative x, we know that we have a horizontal asymptote here, which is y is equal to 0. And from the previous page, we called that as 2 raised to negative horizontal reflection. So you have it like this, the graph of 2 raised to negative x. Now what is the domain and range of this? So domain is from left to right. Yes, it's negative infinity to positive infinity. And the range is everything is above 0. So from 0 to positive infinity. That's correct. Next is 2 raised to x plus 3. So we did this. So we go up 3, 1, meaning this plus 3 meaning is up 3. This part here. So meaning your horizontal asymptote is at 3. So horizontal asymptote y is equal to 3. And 2x plus 3, the graph is something like this. So here, what is the domain and what is the range? Domain, again, left and right, so meaning from negative infinity to positive infinity. And your range is, you have a horizontal asymptote at 3, so it won't touch 3, so everything is above 3, so nothing, so 3 up to positive infinity. And then 2 raised to x minus 2. We did this, an example like this, minus 2 meaning yes, to the right 2. So you still have the same horizontal asymptote at y is equal to 0. You just move your 2 raised to x to the right 2. So sorry, I forgot to show you to graph 2 raised to x. So 2 raised to x is this, the blue ones. This is 2 raised to x. This is 2 raised to x. So the green is the new graph, f of x, h of x, and f of x for number 28 to the right 2. So we just move this to the right 2. 1, 2. So here, this doesn't look good. So this is like, this is to the right too. Alright, so the domain and range of that, the domain is left to right again from negative infinity to positive infinity, and the range is, yes, is also, since you just move it to the left or to the right, it's going to be the same range above 0 to positive infinity. Okay, and that's it for section 4.2. So graphs of exponential functions. So let me know if you have any questions. Thank you.